you should get one. I made extra copies because I figured people would say, I lost it or whatever. Even though I see people throwing them away, but that's life. All right. We read this thing, and on Friday, you're going to have a very similar situation where you're going to have an experiment. It's going to be on the computer, so make sure you bring the computer. So first quiz, and I already gave you the checklist. Let's go down this. I'm going to post it. You have the checklist that tells you what's going to be on the quiz, so you know what's on the quiz. You know it's going to be scientific method, accuracy, and precision. And so I'm telling you right now, what you're going to have is an experiment just very similar to the data nugget. All right, and you're going to have to do the following, the stuff that we're about to do as we go over the answers to the data nugget. As soon as I go over all the answers, that is due in the box with your due date. I'll put that into Schoology today. So I'm going to want these answers on a separate sheet of paper. You keep the questions, but as I go over the answers, so you keep this, because you did it on this theoretically, right? You did it on what I handed out to you. You keep that, put a hole punch it, put the due date, today's date, which is the 22nd, I believe. Is that right? August 22nd. So you put today's date on it, on what you're turning in, and at the top of this, and this goes in the binder for August 22nd. So again, let me draw it out here. And I just want to be clear, because I don't want anybody telling me they didn't know, they didn't understand, when I literally have many examples of me even drawing it out. So on this side, you're going to have your data nugget. The answers that you originally had, you're going to correct them. And you're going to have something you're turning into me with all the answers on it. And then over here, you're going to have today, since this is Thursday, August 22nd, right before the quiz, you're going to have your green checklist that has a summary of everything that's going to happen before tomorrow, since tomorrow is the quiz. Now remember, tomorrow we only have 40 minutes because we have a shortened schedule due to the fact that we have a whole school assembly. The quiz is only 20 minutes long, so that gives you extra time if you need it. Literally, you can have up to double the time. And if the rest of the class is ready and you need more time, we can maybe find another place to take the quiz. So time is not going to be an issue for you. However, I want to emphasize to you that on state exams, on AP exams, on SATs, in the very soon to be future, in the very soon to be present for you, you will have to deal with time constraints. Meaning you're going to have a lot of your tests will end up being timed. All right. So the first as you read through this, has everybody read through this? Let me start with that. I know some people came in late, some people didn't get a copy, even though there were extra copies, didn't know where they were, weren't listening, whatever. This was done a week ago, correct? Yes? I just want to make sure you got this a week ago. Ladies over here, especially those of you that fall off chairs. Do we have, what? Do we, just remember, you came for me first. So when we read, everyone read this, is that correct? Yes. All right. Scientific question. The question, they gave you the question. So remember, how do we start the scientific method? We start with an observation. And the observation is the Arctic is melting. Ouch, that's a big deal. North Pole's melting. Santa Claus is in trouble. Then the next question, the question they asked based on this observation, I'm just breaking down the data nugget into the various parts that we've been talking about. Our observation was the Arctic is melting. Do you see how I'm using an abbreviation? I put OBS. I didn't have to write observation. Then it says a question. And well, first you do research. And they did the research for you. This is an observation. So somebody said, let me go find out what's going on with the Arctic, blah, blah, blah. And they went to the library. They read some papers. And they found out that there were they wrote it in what's called, in this example, and on tomorrow's quiz, they gave you background. Background in a scientific paper is a summary of the research done by the person who did the experiment. So background is when we tell you you have to go do research. Somebody went to the library, and if you're doing research, it's going to be you. Somebody went to the library and looked it up, or somebody got, in the case of a PhD, their background is still looking things up, but they also ended up studying, 6-7 years, that particular topic. A climate scientist may have spent his or her whole life studying climate. That's their background. They know what they're talking about. But how did they get that background? They studied. They went to the library. They read papers. So in a scientific paper, the background is a summary of what's necessary to understand the question, to phrase the question in context. So then you come up, after you do observation, after you do some research, you can form a question. And honestly, when you get a PhD or you become an MD or you become a nurse, it's the question you ask that becomes the most important part of the scientific process. Have anybody here watched House? The show House. Holmes is a good one too, but House is a doctor show. It's an older show. You can watch it, I think, still on Netflix. But it really does drive home the point. The reason House is it's a fantasy. It's not real. That's not really how doctors act and behave and are. But to be a really great doctor, you have to ask the right question. To be a great scientist, you have to ask the right question. In order to ask the right question, you have to have that background, that research. And you have to obviously be, intuitive and intelligent and all that. Yeah, we're all intelligent in this room. The part that we're missing is background. I like how she just looks at her when I say we're all intelligent in this room. I'm just saying. And you missed it. You missed her. Had that joke. All right, so question. The question is based on these climate models. So based on what climate models? The research, the background, right? So based on these climate models, how will the projected decrease in Arctic sea ice affect climate. Around the world. That's the question they're going to ask. And what they're saying is, look, we went to the Arctic, we took a meter stick, we drilled a hole, and we measured the ice. And year after year, what we're seeing as we do this measurement is the levels of ice in the Arctic are going down. They're going in this direction. It's a negative inclination, there's a decrease year after year of how thick the ice gets. And we're worried that at some point, if this keeps going, and they're like, let's extend the line, if this keeps going, in the near future, there won't be ice up there. And so, because this would be a zero, right, on a graph. So if we look at zero, if we take this line, this is the data, I'm going to put in red the data points that we measured. We measured these data points over time. We drew a best fit line, and you saw the best fit line in your study guide. We drew a best fit line, and when we look at this line, if we extend it beyond, this is what we measured. This is the last point we measured. This is this year's depth. But if we extend it, if we say this is how the direction we're going, and we extend it just in a few years, we might get to zero. I mean, that makes sense, right? You've done graphing before. We're going to do graphing in this class. But you understand that if you just extend the line, if this is what we measured, we didn't measure this, right? This is what we're guessing is going to happen. It could go up, right? It could drop even more drastically. It could stay the same. We don't know. Like, what are the different options for this graph? If we think about it, we could have a graph that does, you know what? Let me use the technology I have available to me and just make a copy of it. Let me make several copies. So we're not sure what's going to happen. There are many different things that could happen. What are the possibilities? Who can tell me what might happen in the near future with this graph? Look at it. What's a possibility? Let me zoom in. If we look here, what is a possibility might happen with this graph? This is the last data point here. This is this year. This white line is the best fit line. What might happen in the future? What about next year? Let's say this is next year. What might happen? Another dot where? Lower? Higher? Even lower than we had here? The same? Come on, guys, think. I said there's several right answers. Give me one. And go lower. So one possibility is it could do this. It could, what's it doing? It could, okay, why is it doing that? All right. Is this dead? The pencil dead? No, it's not again. Okay, not going to work with me today. This app is really beginning to bug me. I don't know why it's doing this. All right, it's working. There you go. It could go lower, right? It could do that. Yes, because we could have next year could be zero. Wow, well, how'd that happen? I don't know. We don't know what this is. Let me do this future dot in blue. What is that possible? Yeah, sure, why not? It's possible. What's another possibility for this graph? Stay the same, so it could just flatten out, right? It could just stay that's the lowest it's going to get, because year after year after that, it could just do this, right? Okay. What's another possibility? You can go back up. That's right. And maybe the next year it doesn't go down. Maybe it goes up. And the year after that it goes up even further. It goes up even. It could do this, right? That's another possibility. It could just go straight up in the future. It's pretty much the only thing that can happen. Or it could just do what? What's the last thing? It could just keep going the same direction, right? Maybe it just gets lower, but doesn't go lower any faster. It just kind of keeps doing the same thing it's been doing. Which one do you think the scientists are going to bet on? If you were going to bet money, which one do you think you would bet on? The last one, right? Why would you bet on this one? All of these are possible, right? They're all possible. Why would you bet on this one? Go ahead. You know the answer. It's exact. You're right. You would bet on the last one. You'd bet if I had these labeled A. Let me do another color so we don't get anything confused. A, B, C, and D. If we were gonna bet, you and your friend are like, I'll bet you, I'll wash the dishes if you get this. You and your sister are sitting around the house, or you and your brother sitting around the house. I'll bet you to doing the dishes that I get this right, and I think it's D. Why would you bet on D? All right, let me start again. I'm going to now pay attention and listen and think. 100 years ago, this was the depth of the ice. I kept measuring. I measured for 100 years. I measured, and every year it keeps getting lower and lower at this, according to this white line. Now I'm asking this is today. This is my last measurement today. Now, what am I going to predict in the future? Am I going to predict it's going to flatten out? Am I going to predict it's going to drop? Am I going to predict it's going to go up? Or am I going to predict it's going to keep going the same direction? Why? Because it's been happening like that for 100 years. What's changed? I don't know. I don't think anything's changed. It's the same thing. Have we changed anything, right? It's like... I don't know, what's something that stays the same every day for you? What's a routine for you? Something happens every day for most of your life, this happened. Something happens every day. I mean, the sun comes up, but not at the same time every day, so that doesn't count. Like in my house, my mom would every day, we would wake up to coffee. The smell of coffee. My mom would have coffee brewing in the kitchen every morning, bacon cooking, literally bacon and eggs and coffee every morning for my father. And we would smell that smell of breakfast every morning. That's what woke us up. Every single day. What do I expect? When I was a kid? What did I expect would happen? Did I expect that one day that smell wouldn't be there? No, I expect it's going to be there because that's what's been happening my whole life, right? So if you have a bunch of data points that are going in one direction and you just have to guess, you have to make a hypothesis, you have to guess what's going to happen. You're going to guess according to the trend, correct? The trend in my mother's home was breakfast, the smell of breakfast every morning. The trend, this is called a trend line. You guys have a trend of making TikToks. What'd you all say? Give me the money or whatever, right? Or whatever. Give me my money, right? That's a trend line. So you have a trend. Every time you turn on your TikTok, here, give me my money, or you get somebody to say it. Well, this is the trend in sea ice, the white line. So if I'm going to make a bet, and I'm going to make, and a hypothesis is a prediction, a bet is a prediction, right? You're predicting something's going to happen, and you're putting washing the dishes on the line. Here, we're going to predict that the sea ice is going to continue to go away. Correct? All right. So it says, based on the climate models, How will the projected, by the way, I'm going to say, I think I've said this before, but I'll say it again. Projected also means to predict. It's a synonym for, it can be a synonym for predicting. So when you say, how would the projected decrease? It's very similar to saying, how would the predicted decrease? Why are we predicting? Because of what? Why are we predicting the sea ice is going to keep going down? Because of what? The trend line. The trend is, that's what we're used to. Yeah. Sure. Which were on the words or the graph? So you're welcome. You get the trend line is predicting what's going to happen based on what's always happened. In the fall, the leaves always fall. Is it possible that the leaves don't fall off the trees one fall? Yeah, I guess. But would you predict that? You wouldn't bet on that, would you?
No. I wouldn't.
I wouldn't either, because we have common sense. Or rather, since common sense is not common, let's just say we have good sense. All right? Is everybody okay with that? All right, so let's go on. Let's make a hypothesis now. They say, what's the hypothesis? Well, they say they expected that compared to the control, the treatment models with reduced sea ice would have more extreme weather. So they said, the hypothesis, they said, which is that they're betting that the sea ice is going down. It's going to keep going down. They're saying, well, if that does happen, if the sea ice keeps going down, if the treatment groups it's not really a good way of saying it. Let me think about how to rephrase an if-then statement. We're going to write if. So if you wrote if, it's all right. You're not. If the sea ice keeps going down, then those with less ice would yield or have more extreme weather. And again, what do we mean by extreme? We're talking hurricanes, tornadoes, really hot, really dry, right? And what do we mean by the models? What are those? When I use the word those, what are we talking about? We're talking about the models. So we have model 1, the US model, and the UK model. And we're going to have a treatment group. And a treatment group is the ones with less sea ice. And we're saying we're going to put in less sea ice. What if we put the ones where we say we're going to put some numbers into these models? They're computer models, right? They're computer guesses using math. I'm going to put different values in. If I put a value of less sea ice, because what did we say? There's several options. We could have less sea ice. We could have the same sea ice. We could have even less than we're having, or we can have more sea ice. They're arguing that if we put less in there, then those are going to put out more extreme weather. They're going to say, the models are going to say, we are going to have more extreme weather. All right. So that's what's going to happen. If you put in, they're saying if I put in less sea ice, then the model's going to pump out, more extreme weather. That's what they're going to say. And their argument is the 10th percentile reflects the temperature. You probably don't know what percentile means. You might have covered it in middle school. Percentile means how many, what percentage of, in this case, temperature. If you're in the 90th percentile, that means that you scored better than 90% of the people that took that test. So if you're in the 10th percentile here, the temperatures where 10% of the temperatures values are the 10th percentile reflects a temperature value where 10% of the values are below. So only 10% are below it. So it's a pretty low temperature below the value. Because only a few observations were colder than 10th percentile, only 1 in 10 days, we define it as cold day. See, they're defining cold days and they're defining warm days. And they're saying anything that's colder than, anything that's at the bottom 10%, we're going to call cold. Anything in the upper 90%, we're going to call hot. So if we did a graph of hot and cold, what we would say is like, if this is temperature, and this is and these are days, and we plotted temperature in days, then we would say these are the cold days, the bottom 10%, and the top 10% is going to be the warm days or hot days. Everything else is in the middle. So this is it. This is the 90th percentile. 90th percentile, and this is the bottom 10th percentile. So these are remember I told you that cold and hot, maybe we were making jokes that just because you say it's cold doesn't mean it's cold. You have to have some reference point. Remember we talked about quantitative versus qualitative, correct? Cold is qualitative. Cold is data that's not, if I say it's cold, is that a number? No, it's just an opinion, right? So how do we make that opinion a number? Well, we can measure the temperature and say, look, if it's at the bottom group of temperatures, if the temperature falls here at the bottom end, we're going to call those cold. And if they fall up here in the top 90th, we're going to call them warm. So now I've taken that qualitative data and I've given it some numbers. That lets us do some calculations. Is that fair? Are we okay with that? Okay. So it goes on and they talk about 10 percentile. And then they look at the historic data and they put it all in a graph. This is the graph that confused everybody. So let's take a look. So these are different models. They use the different models in different places. Obviously, you're going to have to. Climate's going to be different in the desert than it is in the mountains, than it is in Europe versus Canada, right? You wouldn't expect the climate to be the same in East Asia as you would in Canada, would you? No. So what do you see at the bottom of this figure? That's right. And what does that mean? Why do they have those cold days, warm days? What does that mean? Why do they have those symbols? And what do we call that when we have a graph or a figure? Say that? A legend. Excellent. That's your legend. So cold days, again, those bottom 10 percentile, they're going to have a little thermometer, and they have and they fill in the, oh, for Pete's sakes, you guys are ridiculous.
What'd you say?
You're ridiculous.
How are we ridiculous?
I heard your little giggling.
I can't giggle and crackle. Like, I can't.
You can.
Like,
I didn't say anything about it except it's ridiculous.
how loud?
I can't do this right without. So let's just say this. Let's put a snowflake, and the other symbol that's there. They do a much better job, and that's gonna be your cold days. And then the warm days, they're gonna have that same symbol with the thermometer higher up. In fact, I'm not even gonna do the bulb. I'm just gonna do the rod, and I'm gonna say the cold days are down here, right? And over here, the warm days are all the way up, right? So we have cold and warm. And then wet days are represented by what? Raindrops?
Yeah.
All right. So wet days are going to be raindrops. And then dry days, they're gonna represent it by having this kind of wilted plant. And that makes sense, right? Because what do plants do when they get dry? They wilt. And we'll talk about why that happens later. So those are three symbols that they're giving. They're only looking at three different aspects of climate. How wet it is, how dry it is, how warm it is, or how cold it is. That's it. So according to the models, in Alaska, it's going to be, in Canada, it's going to be much warmer in northern Alaska. It's going to be colder in southern Alaska. It's going to be wetter in Canada. Do you see that? In western Canada. You see it in Greenland, it's going to be warmer in upper Greenland. It's going to be colder in southern Greenland. And it's going to be wetter in East Canada. You see how the models are saying? That's what they're saying. So we're predicting that these are going to be extremes. So when they say wetter, they mean floods. When they say drier, they mean droughts. When they say warmer, they're talking 100, 110 degree weather. It would be 102, 104 degree weather here in Cleveland. But in Alaska, it might be, whatever warm is for Alaska. And so that's how you read that graph, that figure. Do you see that? Do you see how you read it? So those are the results. They put it in the form of a figure. Those are your results from the experiment. So then they ask you some questions. Let's go to the questions. What is the independent variable in this experiment? Now that I've described the experiment as completely as I could, what's the independent variable? What am I changing, and what's the dependent variable? What's changing because I changed it? See, this is going to be on the quiz tomorrow, dependent, independent variable, right? They took a look at the data and compared the results of the controlled treatment groups, looking for different differences between the two. So what was the independent variable and what was the dependent variable? What changed because something else changed? What did they change? When they put it into the model, they put a value into the model. What is it that they changed? What changed because they changed the value? Well, let's go back and look at this. What was the hypothesis? If the ice keeps decreasing, then those days with less ice would be more extreme. And what value did they put into the model? What is the value they put into the model? Somebody said it. Less what? Sea ice. That's right. So the independent value is sea ice level. So you got it. So they said, well, if I put less in there, then I get more extreme. So what is the dependent variable? That's right. how many extreme weather events? Right? So the dependent variable is how many extreme weather events. The independent variable is the sea ice level. So what would you say? What was the control group, by the way? Can somebody find me the control group in the reading? Current sea ice levels, correct. So your control group is the control group was the current sea ice levels. And if those are the current sea ice levels and we change that level of ice, that's us changing that value that's going into the model. So then the independent variable is the sea ice level, and the dependent is how many extreme events. Okay. And then here they tell you all these different extreme events are going to happen. It looks like the central U.S. is going to have drought and low temperatures. On the East Coast, in the central U.S., you're going to have high temperatures. Low temperatures and a lot of precipitation. In the West, you're going to have more precipitation and lower temperatures. So you're going to have a lot of different. So how many cold days were there? Look at it. Count. How many cold days? All around the world. Because this is the question, the hypothesis was all around the world. So we're counting all the extreme cold events. How many do the models predict around the world? How many? 7. According to you, I haven't counted them, so I'm going to go by what you said. So you counted 7 temperatures with a down arrow, correct? With a little snowflake. So 7 of them. So you would put in cold days 7 extreme weather events all around the world. How many in warm days? How many warm days? How many 90th percentile, which means extreme heat, are we going to have around the world? 4. So 4 warm days. How many wet days? 7. And how many dry days? 6. All right. So now, so these are 7 more days than the control. How many warm days? Again, you counted them already. 6 more than the control. What about the wet? 7 more than the control. And dry days? 6 more than the control. So now answer the hypothesis. Answer the question. What was the question? Going back to our notes. Notice these are notes. Based on the climate models, how will the projected decrease in Arctic sea ice affect the climate around the world? What would you say? The hypothesis is if the sea ice keeps decreasing, those with less sea ice would have more extreme weather. Do we have more extreme weather or not? Yes, we do. If with less sea ice, we have more extreme weather. How do you know? You counted them. You wrote it down. Correct? Now, can you handle writing because we only got a minute or so left. Can you handle writing the rest of these answers down? What evidence was used to write your claim? The evidence that we recorded off the figure, right? Explain your reasoning on why the evidence in the model supports your claim. Connect the data back to, well, you would say, we have 7 more. I'm going to make these up because I don't remember what you wrote down. 7 more cold days and 6 more dry days, whatever, right? Yes? Than the control. More than the control. Did the data support James's hypothesis? Use the evidence to explain. Since there were more, with less sea ice, there was more extreme weather. Yes, the data did support the hypothesis, correct? Yeah. Okay. What else could you do? What could James do in the future? How would you build on these questions? How much more? Could we do something about it? Could we change it? Could we add, is there a way to add sea ice? What if, there's a lot of other questions. What is increasing the temperature? What's melting the ice? So these are questions you can be asking. So I think I gave you all the answers. Whatever you wrote down today, put it there. Keep your questions. Review. Make sure you know your scientific method. For tomorrow, you'll have a 20-minute quiz and plenty of time to do it in. So it's a new day, and what we're dealing with here is on page 6 now. And page 6 asks what evidence was used to write your claim. Now they asked you to write a claim and make a claim that answers a scientific question. Well, you have to go all the way back to the scientific question. The question was, based on these climate models, how will the projected decrease in Arctic sea ice affect climate around the world? So it says, we wrote a statement a claim to the scientific question, and the claim that I believe we wrote, and I can't remember what we wrote, but I'm just going to go ahead and write a claim. What claim would you write based on the data that in that table? The loss in sea ice, what impact did it have on global climate change? On global climate? What was the question? What was the answer somebody asked or answered? The temperature changed? Okay. In different locations, it changed differently, didn't it? It didn't all change the same, right? We used to say global warming. You ever hear that, global warming? We don't say that anymore because in some places it got drier. In some places it got wetter. Although on average, the whole place got cold. The whole world got warmer. That's why it was called global warming. But in some places they got colder. Yeah. Yeah. That's why we call it global climate change now. So what can we say about to answer the hypothesis? By the way, what was our hypothesis? That our hypothesis was that as the Arctic sea ice decreased, the climate would change. Yeah, this is the first question on page 6. Then we made a claim on page 5. We made a claim. That claim, based on this hypothesis, was what? Yeah. Oh, you need a packet? I don't have one. I have this one, but I'll have to borrow someone else's. Oh, there might be extras. I printed extras for people. What was the claim that we made? Here's one. What was the claim that we made? What do they mean by the word claim? Do you know what the word claim means? Can anybody tell me? What does the word claim mean? I hear silence. I know you told me it's early in the morning, but come on, guys. Claim. You've never heard the word claim? What does it mean to you? You're claiming it as yours? That's true. When you're claiming it as yours, you're saying, this is mine. You're making a statement. You're claiming it. You're saying, this is mine. The claim part, the definition of claim, is a statement. You're making a statement. So write that down, because obviously, there's always new words we have to learn. If you don't know it, you should learn it. This is an important word you're going to see a lot. Claim. Claim means to state. I state this is. This is my statement. Claim is another word. Is synonymous. One definition, one way of looking at the word claim is to make a statement. Yes, during the gold rush, you can have a claim, but all that is an official statement that this belongs to you. Does that make sense? So claim means a statement. So what claim can you make that answers the question? What claim can you make that answers the question? I'm looking at anybody. Yeah.
I said if the warm days start to increase, the ice will melt and the climate will change and get hotter.
Get hotter. I like that. I like it all the way up until it gets hotter, because did the temperature get hotter everywhere in the world? And not according to. Let me see. Did it? No. In the eastern United States, it looks like it's getting colder. You notice that? So we could say. So I would argue that we could make a statement that says, as the Arctic, not Arctic. Huh? It's an answer to a question, right? It's number 6. It's the claim. You should have answered it on page 5. So it says page 5 underneath the table. It says make a claim that answers the scientific question, right? So as the Arctic sea ice decreases, according, comma, I'm going to put a comma, according to the two models, the global climate will change differently I'm going to use a word that actually makes more sense, but you may not have heard it before. Differentially. That just means different in different places. You see the root word, right? Different.
You said
Huh? On page 5? You don't have page 5? At the bottom, look at the bottom. It says make a claim.
Yeah.
That's this. The claim. That's what we're doing. Is that good? So it doesn't have to be in these words. It could be any words you want that mean the same thing. Right? Bless you. That's the great thing about short answers. There's a lot of different right answers. You saw the danger of multiple choice. The danger of multiple choice is that you either got it right or wrong. Right? With short answers, the good news is there's a lot of ways to get it right, but then there's a lot of ways to get it wrong. So as the Arctic sea ice decreases, according to 2 models, the global climate will change differentially, which means it'll change differently in different places. Does that make sense? Are we good with that? Yeah. No, this is still the claim. We're still wording the claim. This on page 5, at the bottom of page 5. Is everybody with me? We're trying, in order to start on page 6, we have to have a claim. See the bottom, page 5, it says claim. What claim can you make that answers the question? All right, so let's try again. We started with a question. First, we started with an observation. And I think it's worth us going back. We started with an observation. Observation is Arctic sea ice is melting. So then we said, so what? So we formed a question. We said, what impact does the decrease in sea ice have on the global climate? That decrease in sea ice could have a lot of impacts. It could. You can ask a completely different question. You could ask the question, what impact will the decrease in sea ice have on the polar bears? That's a question you can ask. You can ask a question like,
is Hayden Green here?
Hayden Green, she has, yeah. I did submit it to the office.
Thank you.
So we can ask from that one observation, we can ask a lot of questions. Does that make sense? Some of you are zoning out. I really wish you would not zone out because this is essential. You have an observation, right? There's a famous one. Newton was sitting under the apple tree and the apple fell on his head. And that led him to think about gravity. Correct? The apple falling on his head, he could have thought about luck. And he could have went and started to calculate the odds of an apple hitting his head. He could have thought about, why do apples fall off a tree? And he could have went down the road of biology. He could have studied biology and started learning on why fruits fall from trees. He could have asked a lot of questions from that apple hitting him on the head. He ended up asking about gravity. And that led to the theory of gravity. Okay. Here we have Arctic sea ice is melting. We could ask, why is it melting? We could ask, has it ever melted before in the history of the planet? We can ask, what's the impact on polar bears? We can ask, what's the impact on fish? We could ask, what's the impact on seals? Like, there's a lot of questions we can ask. If the sea ice is melting, we could ask, how does that impact shipping? You know, we send stuff from China to America. We send stuff from Europe to America. Right now, we use the Panama Canal. I don't know if you know that, but in Panama, we have to get stuff from the Atlantic to the Pacific. It used to be you had to go all the way down beyond South America, to go all the way around all the continents, to go up into the Pacific. That's how Darwin and his people would get all the way around the world. In order to get from one side of the world to the other, you had to go all the way down past the tip of South America and then come back up. The Arctic was ice. It was pure ice, even in the summer. So we dug a giant canal that would allow ships to go from the Atlantic to the Pacific. You know, there's two different oceans, yeah? Atlantic's on the east coast, Pacific's on the west coast. So you could ask, well, if the sea ice is melting, how does that impact us shipping stuff around the world? That's good for us. We can ship things a lot faster, and we don't have to worry about going all the way down to Panama to get it to the Pacific. It's bad for us in many other ways. So now we ask a question. The question we asked, though, was none of that. What did we ask? How is the melting sea ice going to impact global climate? We came up with a hypothesis. We actually read the hypothesis. It said it. Correct? We found it. And in fact, that was one of the questions they asked us to do. Find the hypothesis. We found the hypothesis, correct? Okay. Then it asked us to make a claim that answers the question. And the claim that the question is, how does the melting sea ice impact global climate? And I should add global here. Oh. Yeah, okay, that's right. And our hypothesis was, as the Arctic sea ice would decrease, the global climate would change. That's what we said. Okay. Then what is the claim? We did the research, we looked at the data, and what did we decide? What statement can we make that answers the question? What's the claim that we can stand on? Come on, stand on business. Oh, come on. I can use it any way I want. It didn't even exist 10 years ago. All right, come on. What is it then? Yeah, anybody. I'm doing all the talking, and I'm kind of getting sick of it. Come on, guys. Give me some help here. Yeah. I already wrote the answer down. Do you all see that this answer, I already stated it. It's already stated. Yeah, she did say it, but I want people I want other people to. Oh, okay, my bad. We already answered this question. The claim is here. The observation led to a question. The question led to a hypothesis. The hypothesis led to a claim, to an answer, to a statement. And this is our statement. Now they're asking you what? What are they asking you on page 6? Does everybody get this? What evidence? That's right. What evidence? Because anytime in science, anytime you're looking in science, in social studies, in English, on NAAP exam, on SAT exams, anything, they're going to ask you to answer the question, make a claim, then support it with evidence. You're going to do this in English. You're going to write papers. They're going to ask you for an opinion. Make a statement, an argumentative essay. You're going to make a statement, and then you're going to defend it with evidence. Now, let's go ahead and answer the question, what evidence can we use? So for evidence, you could have used anything. You could have used anything on that graph. As we put data into the models, the results showed and I'm just going to put 1, But I would put 3. 1, 2, 3. I would put 3 I would put 3. I would say the eastern U.S. would decrease in temperature and decrease in rainfall. U.S., yeah. U and S. East U.S. would decrease in temperature and decrease in rainfall. I'll do another one for you. The Mediterranean would increase in, it doesn't say what. Increase, it looks like, I can't tell, I guess in everything. In temperature. It's an arrow down. It's a way to make things, instead of writing the word decrease, just down arrow. By that? Mediterranean. Let me. We got 2 minutes left. Mediterranean, and then we have a third one. You can come up with the third piece of evidence. So any of that evidence on that chart, right? That chart shows you all the changes that the model predicts is going to happen. Correct? Explain your reasoning. So what they're going to want you to do, what you're going to have to do repeatedly, what you're going to have to do repeatedly all year long, is make a claim that answers a question. Then provide evidence for that claim, and then explain your reasoning. Claim, evidence, reasoning. Claim, evidence, reasoning. Claim, evidence, reasoning. 1, 2, 3. 3 things you're going to have to do all day long. Every day. So try to finish these last 2. I will finish these answers in the rest of the classes, hopefully. And I will post those answers, okay? So you will have them. If you have questions, I will be here after school today. All right? Are we feeling good about today? We're all okay? Come on, wake up already. I hate that I get you this early in the morning. I bet you're amazing in the afternoon. I bet you're amazing. You're not amazing in the afternoons? Why does that look side-eye? Why are you side-eyeing? Come on, you're amazing kids. You have to be amazing. You obviously have bright eyes, you just don't have any speech coming in. Your eyes are bright. I see they're open. They're looking around. You're not laying your head down. Some people are writing. Some people have already written the answers. They have the answers. They're just bored. Others are just all... some of you woke up and got all dressed up. You put bows in your hair. You did all kinds of stuff to get ready. So it's not like you just woke up. I feel like I just woke up. You're a lot. What did they used to say when I was your age? Bright-eyed and bushy-tailed. All right, I'm going to go ahead and record the answer here. So after you have the evidence, you come up with the reasoning. And the reasoning here, although obvious, it should match your claim. Since the models clearly show change around the world in temperature, precipitation, I think that's it, temperature and precipitation. and precipitation. It is evident that the data supports the hypothesis. That's it. Just that clear. I asked myself, did the evidence match my statement? It did. It supported the hypothesis. I'm done. Claim, evidence, reasoning. I guarantee you there will be people in this room that will make a claim and reason the opposite. There will be people that make a claim and the evidence will show exactly the opposite. And they're not, and the reason they're doing that is they're making a claim. They're not thinking about how the evidence affects that claim. They're just saying, I think I'm right, I'm going to go with it. That's what I remember someone saying, so that's what I'm going to go with it. And it's going to be obvious it's wrong, but you're not reflecting, so you don't notice it. Did the data support James's hypothesis? And that answered that question as well. Yes, it supported the hypothesis, and that's why you made the statement you did. So what kinds of questions could you ask? Can anybody think of what kinds of questions you might ask based on these results? To build on the question? You might ask a question, some future questions might be, how fast, by how much will climate change? How much sea ice These are extra questions. They're not. We don't have the data to support this question. We have to go and collect it. How much sea ice needs to be lost to get an effect? So, and you can go on. There's 100,000 questions you can ask. What's the impact on polar bears with the loss of sea ice? What's the impact? Those are different questions. They're not building on this research. What's the impact of global climate change on our food supply? What's the impact of global climate change on war? In fact, the Pentagon has done some studies that said that global climate change is going to increase war around the world. We're going to have what they call water wars because there's going to be droughts. We expected there to be droughts, and there are droughts in Texas and California. With droughts comes a fight for water. California and Texas have already petitioned for us. We've denied it, but they petitioned to build a pipeline from Lake Erie to Texas. Why did Ohio say no? Yeah.
Because that's kind of our water source.
It's our water source. And for them to take it would mean that they would dry us up. And we have a treaty with Canada that says how much water we can take out of Lake Erie. Because we don't want to end up like these other places that are literally drying up. The Colorado River runs from the north around the northern part of the United States all the way down to Mexico. Naturally, the water flows. It's so much water, it created the Grand Canyon. It cut through the earth and created the Grand Canyon. That's how much water. Do you know that but today, it doesn't reach Mexico? We've used up all the water before it gets to Mexico. So there's a lot of issues that we could talk about, how global climate change then is going to impact what? And so there's a lot of future questions you can ask is the point. All right, so yes, I'm glad we finished the data nugget in this class. I'm glad we were able to get this recorded for the other classes that need it. But now let's talk about this idea of pseudoscience. It's in your chapter reading, if you read it. Does anybody know what pseudoscience is? See, now it's not right. Who knows what pseudoscience means? Who knows what the prefix pseudo means? Yeah. False. False science. False science is used to hold up horrible concepts all over the place. False science where has false science been used to hold up anti-vaxxers? Have you heard of these anti-vaxxers? False science has impacted racism. And in fact has held up, I'll give you a couple examples. False science or pseudoscience has impacted global climate change. And pseudoscience or false science has even impacted the cigarette companies. I should say, smoking, drinking, driving, obesity, there's just so many, everything impacts life in general. False science is used to support it. And at the same time, many of these people will say scientists are full of it, but they're the ones causing the false science. In fact, some of these people with the false science are scientists. So I'm going to use vaxxers, anti-vaxxers as an example. So this started, I want to say it started, may have started before this. Let me give you the history of vaccinations real quick, and then let me give you the history then of anti-vaxxers so you can see where pseudoscience can really start. And then we'll talk a little bit about racism. And it's where I think I've read a couple books where that suggest that this is really the start of it, of racism. Because racism wasn't always around. We always found reasons to fight each other, right? But in time before slavery, people of African descent weren't necessarily thought of as less. They just were different. Have you read Shakespeare at all? Have you ever heard of a character known as Othello? He was an African Moor, an African general. So Shakespeare, a British writer in the 1600s, was writing about a black general running an army of Europeans. This is before slavery. And then somehow slavery happens in America and all over the world, and then all of a sudden we have all these different races. Races were not actually a consideration. It was nations. You were French, or you were English, or you were Swedish, or you're German, or there wasn't this idea of different groups of humans that were somehow separated the way we do today. We know race is not a real thing. It's just something we create. African American culture is a real thing, but race is not a real thing. But let's look at anti-vaxxers and vaccination. So vaccination started probably in the earliest that I know of, and maybe an earlier one, but I don't know. Smallpox. You've heard of smallpox? During the Revolutionary War. Have you ever seen anyone with chicken pox?
Yeah.
Oh, you have. You get these bumps all over your face and all over your body. They're all over your body. And it's a viral infection. It's a virus that invades your body. And it makes your skin break out. And it gives you fevers and impacts your nervous system. It's not just like zits or acne. Acne is a bacteria. That's different. But it looks a lot like acne in that you get these little red bumps, and then they'll pop open. The pus will start coming out. The pus is full of viruses, white blood cells and viruses. And that spreads. But the interesting thing is, they didn't understand this in the days of the Revolutionary War. But they did notice that someone who was infected from the pus of someone who was sick either didn't get sick or got less sick. So they would have smallpox parties where they get together, they bring their kids, and the families would all get together, and they'd bring in somebody who was sick, had smallpox all over their bodies. They'd take a needle, they'd poke the pustule, get the pus on the needle, and stick someone else. Not ideal, not the way to do it, but it helped. So a lot of people survived because of it. A lot of people died because of it, because you were infecting someone with live virus, right? With functional virus. That's not the greatest idea. Well, later, what happened was that developed into this idea of attenuated. In other words, what they would do is they would take that virus, they grow it in eggs, in chicken eggs, and that's what we do with the flu virus, for instance. We grow them in chicken eggs, we let it multiply or whatever, and then we boil it. We break it up into pieces, so they're not functional. Does that make sense? We break it up, so the virus it can't infect anyone because it's not working, but all the parts are there, it's just that they're not put together. We call that attenuated. And then we inject that instead of injecting the actual virus. Now, unfortunately, because of the process, sometimes, maybe 1 in a million, the virus is still alive. So that person might get sick. So occasionally some people got sick, but the majority of people didn't, right? And the other thing about it is this is not 100%. There's no vaccines 100%. I mean, you can get maybe 60% preventative, maybe you get 90%. I don't know what the highest would be, but 90% preventative. It's always going to be 10% they're going to get sick anyways. It's always going to be 40%, always get sick. Some percentage, I think I've seen it as low as 30%. So vaccination is not 100% preventative. Is that clear? Never is. But if you're giving me a choice between 0% protection and 60% protection, I'll take that. I'll take the 60%. It's like going to war and not wearing your Kevlar vest. Like, okay, if they shoot me in the head, I'm dead, right? But I got a vest. If I get shot in the chest, at least I might survive. I'll wear the vest, okay? At least. I'm wearing a helmet and a vest. A vaccination is very much the same idea. It's not 100%. And some people do get sick. And some people have an allergic reaction to it. They also get allergic. That's another thing about this. And by the way, today we actually don't even put in attenuated strands. What we do is we sequence the DNA. You don't know what this is yet, and then make the proteins. So we just inject you with the proteins in a lot of these vaccinations. Some of them are still attenuated. And then the last, what we do now is we have RNA, which is like the new COVID one. By the way, it was never new. We've been working on RNA vaccinations for 20 years. So we inject you with RNA. That means we have 2 minutes left in class. We have RNA vaccines. None of these are 100%. All of them have like this different percentage depending on how quickly the virus mutates, how many different strains there are. They can all lead to side effects that come from allergic reactions. So that's the history and truth about this is the actual science, outline of the actual science of vaccinations. These are the facts. These are facts, not my opinion. Now, the anti-vaxxers, I want to say 20 years ago, but it might be more than that, some scientist, I forget his name, lied. A scientist lied and said that vaccines cause autism. That's what he said. His study, he published a study, it was published, that said vaccines cause autism. That was a lie. He was caught in a lie. They stripped him of they fired him from his job. They proved the paper false. It was, remember, we can't prove it correct. All we can do is prove it false. We've shown the work. It's clear vaccines do not cause autism, but still people feel that there's some conspiracy afoot. But because someone lied, people today still think that vaccines cause all kinds of problems. They cause issues. Can they? Can they cause issues? Yes. But the majority of people, majority of the time, they don't. Seatbelts. Could a seatbelt kill? Why are we putting stuff away? Did I say put stuff away? I said 2 minutes. I have 2 minutes. That's not, it's time to go. So, can a seatbelt kill you if you get in a car accident? Sure. You could be in a car accident, the car could be sinking in the river, the seatbelt's stuck, and you drown because you're stuck in the seatbelt. So why do you put seatbelts on?
Because it gives you a higher chance of survival.
Higher chance of survival. The odds are the seatbelt's going to save you, not kill you. But the seatbelt could kill you. It's possible. It's the same logic, the reasoning, right? Claim evidence reasoning. It's the same reasoning with vaccines. Could a vaccine do all kinds of bad things to you? Yes, it can. It's possible. 1 in a million? Sure. I think it's 1 in a million, or in some cases for some side effects, 1 in a billion. But, or 1 in 100 million, something like that. But when you're talking about what percentage actually get the benefit of vaccines, then it's the vast majority. And then if we get herd immunity, then the virus dies out. We got rid of smallpox. That's how we got rid of smallpox. That's how it went away. Polio. That's how it went away. Vaccines. Not, any other. We didn't just sit around and just get polio until everybody that was weak was dead, which is what some people want to argue. All right, let's go on. Get out of here. Have a good one. We'll finish this discussion of pseudoscience tomorrow. I love Dolly Parton. She loves that Beyonce redid one of her songs, and she loved it. She said it was well done. She wouldn't have done it that way, but that's why she's Beyonce. is what she said. A very beautiful lady. Always a country music singer from the beginning, but always fought against racism. And so that's a big thing for a Southern woman. And that's a Southern white woman. She could have easily went the other way. So I'm glad you're wearing this shirt.
Thank you.
Yeah, what's up?
When do I take my test? Like, that I heard last week?
The today's after school on Wednesday. Or today after school. If you want to wait till next week, Wednesday or Thursday, you can. But we have a test next Thursday, so be careful.
So, should I do it today?
Yeah, you can do it. I'll be here.
What do I get these videos? Because I missed
On the YouTube channel.
what is it?
It's time 010. I'll send it to you. I'll send it to Jupiter. Is that good? I'll send it fourth period. If you don't see it by fourth period in your Jupiter, could you come before you go to lunch or remind me? What is it? Your answers? You can type them into the thing, or you can just leave them here on later. Or you can take it back and finish it. Whatever you want. I would scan, take a picture and submit it, upload it, and then at home, and then just finish it and resubmit it later.
Okay, I think I like to pay.
It's not gonna be late. Remember, wait, when did you turn it?
I turned it in like either last week or before.
You can't be a week before, because I grade every week might have been this Friday, because this has been a crazy week, so I'll grade everything that's in there now today. Okay? Yeah, you want to retake the quiz today after school is good. I won't be here tomorrow after school.
I got high step after school.
I don't know how else we can do it. Can't be before school. Can you be late to high step and just tell your coach you have to make it out? I can write you a note. That'll help. The quiz shouldn't take you that long, and I'll write you a note. You're welcome. Hello, guys. I'm so happy that you guys are actually awake. My first two classes have been out of it. I feel like what they did, what you all did, is had a party yesterday, and then my first two periods had a hangover. Like they were just sitting here like,